Welcome to the subject of microcontroller. This is Professor Minakshi Pancha from Electronics and Telecommunication Department, Parvatibai Ganba, Mojay College of Engineering, Waguli, Pune. So in this lecture, we are going to discuss about clock oscillator, data pointers and program counters of 8051 microcontroller. Let's see one by one. The 8051 has on-chip oscillator but need an external clock to run it. The oscillator circuit that generates the clock pulses so that all the internal operations are oscillators. Connections pins are XT-AL1 and XT-AL2 are provided to connect a resonating network comprising a crystal and capacitor to form an oscillator. Here there are already oscillator circuits is provided in itself a microcontroller, but running those oscillators we have to provide a external clock pulses to that oscillator. The oscillator circuit we are going to connect in between these two pins, the pin number 18 and 19. These the oscillator circuit contains a crystal or ceramic or resonant oscillator. Normally, quartz crystal is used, but normally the oscillator quartz crystal is used generally. And there are two capacitors are used for stabilizing the operations of this oscillator. And these capacitors are size is 30 picofarad. Capacitor size is 30 picofarad. The capacitor used in order to stabilize the network. The crystal oscillator or crystal frequency is the internal clock frequency of the microcontroller. What the crystal oscillator frequency is providing, that frequency itself a microcontroller frequency. The manufacturer provide 8051 microcontroller designs that run a frequency ranging from 1 megahertz to 16 megahertz. So this is the frequency of 8051 microcontroller. And also the resonant network is also called oscillator circuit where produce pulses to synchronize the internal operations. And here quad crystals are used. This is the frequency pulses. In this form, the oscillator will produce the pulses. These kinds of pulses it will produce by the oscillator. And here we can consider 12 pulse, 12 starting pulse. 12 starting pulse is equal to one state. Yeah, 12, two starting pulse, sorry. Two starting pulse is equal to one state. And each six state equal to one machine cycle. They have mentioned. Each machine cycle consists of 6 stages and each state consists of 2 pulses. So one machine cycle consists of 12 pulses. This is the information about the clock and oscillators circuit used for 8051 microcontroller. And this is the simple formula where we can find the time execution of particular instruction. T instruction is nothing but time to execute an instruction that's equal to C into 12 divided by F, where here C is the number of cycle. Here C is the number of cycle. 12 is the frequency of crystal frequency. What this crystal oscillator providing a frequency that C is the number of instruction into 12. This is the simple formula for calculating the time execution. Using this formula, frequency we can also calculate. So So next see the program counter. What is the program? Uh, the program, it is a 16-bit register. It points to the address for the internal or next instruction to be executed from the ROM and access from 000 to FFFF. The use uh, the use of this program counter, which is hold the address of instructions in the memory. It is hold the address of instructions in the memory, which keeps the track of the execution of the program. The program instruction byte are fetched from the location in the memory that are addressed by the program counter, which keep the track of if certain programs, the list of program is going to be executed. The program counter is a one of the registers which holds the address of next instruction. If one instruction is executed, the next instruction address will hold by program counter, which is having whole track how the instructions is executing and where the result is storing, and all those track will be held in this program counter. It's normally start from 000 to FFFH. Whenever power switch off of the microcontroller, that time the PC program counter is automatically reset or it will store 000H. Executing each instruction, program counter automatically increment by 1 after fetching the byte of one memory. If one memory is fetched, then address exists, and after executing that instruction, then it will increment automatically at one point and again access the memory to fetch the address. This is the main task of this program counter, and it is only a single register which is does not have any internal address. There is no internal address for the program count. It can access the program counter access up to 64K of the memory, and which is automatically incremented after completing the current instruction. Here the figure below shows the part of block diagram of the architecture of 8051 microcontroller. The highlighted rectangular box which shows the location of program counter. In case of the instruction like a jump and call interrupt, the content of PC may be changed. The PC is nothing but here program counter, which is only a register but does not have any internal address. I have already told. Let's come to the next. This is a data pointer. What's the data pointer? Data pointer is a 16-bit register, which is also 16-bit register. It is used to hold the address of data in a memory, where the program counter with what it can do. The program counter it will hold the address of the memory or the instruction. Here, the program counter will be used to hold the address of the data in the memory. Data address will be held in this memory, and it can be hold as 16-bit data register or two independent 8-bit address 8-bit register. Sorry, one is a 16-bit. The program counter was 8-bit, but this one is a 16-bit register. Here, uh, in 16-bit register, two independent 8-bit as a two independent 8-bit register we can use. One is a two data pointer lower and data pointer is higher. So there are two separately data pointer we can use here, and it serves the base register in case of instruction handling and lookup table and external data transfer. The data pointer register can be accessed separately as a lower 8-bit and higher 8-bit. Here lower 8-bit is called as DPL and higher 8-bit is called as DPH. Or 8-bit register. The address of DPL is a 82H and the address of DPH is 83. This address of this DPL is Address of DPM is 82H. And this one is here in this figure. We can see the DPL, sorry, the data pointer is splitted or used as two 8-bit register. One is a DPL, data point lower byte will be fetched by using this one, and DPH, the low higher byte of the data address can be stored in this DPH part. The address of these two are, they have mentioned side of this diagram, and data pointer does not have a single internal address. Instead, DPL and DPH are each assigned a separate address. See, we cannot assign the single address for the data pointer. There are a two different address, one for DPL and DPH. If we want to assign to 16-bit address, we have to go one by one. First, we have to go through this address, and after we have moved for this. This is about the data pointer. This is the stack pointer. Your stack pointer is a reserved area of the memory in the RAM where temporary information may be stored. What is the stack pointer? Which is the area of the memory. It's a part of area of the memory in the RAM where temporary information may be stored. This is also 8-bit stack pointer, and which is used to hold the address of most recent stack entry. This location, which has the most recent entry, is called as top of the stack. When the information is written on the stack, the operation is called as push. This is the block diagram of 8051 architecture. This rectangular highlighted box will show the stack pointer. This is a 8-bit register and which can point any location into the internal RAM from 0 to 127 kbyte. And when we have written the instruction into the stack memory, that operation is called as a push operation. And when the information read from the stack, then that operation is called as a pop operation. Here we have not written here, we'll return. When write, called as when read, this is called as pop. When the information is written into the stack memory or into the stack area, then that operation is called as a push operation. When the information is read from the stack, then that operation is called as a pop operation. The pop works on the principle of last in and first out, or first in or last out. When it is reset, the register is initialized to 0, 7H. The stack works on the principle of last in, first out. See in this figure, this is the operation of push. Here 1, 2, 3 data we are going to write here. 3 times of data we are going to write. See, this one is first and second one third. This is writing, but while reading, how we are going to read? Last one first in. When third one is first reading, second one is second, then this is the way. How? Last in, first out. Here the last in this push operation, last in is 3. 1, 2, 3. This is the last in, but in read operation we have to read first one. Hence it is called as last in, first out operation. Otherwise first in and last out. This is first in. This one is for number one instruction is writing first here, then reading last at last. Reading at last. Here this is stack works. This is a principle of stack works. That is last in, first out, or first in, last out. This is the principle of the stack, how it is working. When the information when the information is written first, it will read by last. The microcontroller stores the information or data like a stacking plate. Here here the figure we have shows here. This is the storing the data method, how it is going to store. I have stored first instruction here. I have stored first instruction. Then what will happen here? Increment and then store. If my stack pointer is here now, I want to store some information. Before storing the information, it will increment 1 and then store the data. Then in previously it was location on 7. Then I want to store the data. Then it will increment to first. It will become 8th position. Then it store the data. Again, if again I want to write the instruction into the stack memory, then again it will increment by first. First it will increment, then store the data. First increment, it will store the data. This is the process for storing the data. And same here, reading the data and getting the data from the stack. First we have to, what we'll have, first we have to get the data here. We have to get the data and we will decrement. We have get the data and decrement to one position or one memory. Then again the get the data and it will decrement to one position. This is the writing and reading, how to store the data and how to get the data. Before writing the data or before storing the data, it will increment first, then store. It will increment and then store. It will increment first, then store. Again increment first, then store. Yeah. But here now it will first decrement. Sorry, here first read the data. Here first read the data, then decrement. Read the data, decrement. Here get the data, decrement. This is the principle of the stack pointer. The stack is implemented with the help of special memory pointer register, can called as stack pointer, and it is a 8-bit. The stack pointer can take the value from 00 to FFH on power up, and SP contain the stack pointer contain the value 07H. When the stack pointer get restart or 8051 power off after starting on, the stack pointer hold the address 0H. 0H. This holds the address 0. Sorry, 7H. 7H. When stack pointer restart or power is off, then this will become 07H. This holds the address. If you want to write the data from 078, it will increment to 8, then store the data, increment to 9, then store the data, and after read the data and decrement one step, read the data, decrement up to 7. When the data is to be stored on the stack, the SP is incremented before storing the data, as I said, on the stack, and then the data is to be retrieved or popped from the. When SP is decremented to the point, the next available byte of the store the data. The stack array can reside anywhere in the on-chip RAM, wherever its height is limited to size of the internal RAM. On the memory, anywhere or what part of the memory can be assigned for the stack operation, but size of this stack is limited and less than the internal RAM. The location 08H21FH is 8051 RAM can be used for the stack. Normally from 08H to 1FH is generally used as a location of the RAM, location for the stack from the RAM. It is because the location from 20 to 2FH of the RAM are reserved for bit addressable memory and it cannot be used by the stack. So from the memory, normally from the memory location 08H to 1FH, the RAM is normally used as stack. Above that, from 20 to 2FH, it is a bit addressable memory, hence stack cannot use this. If in the program we need more than 24 byte of the stack, we can change SP point to RAM location 3027FH. The stack can retrieve the data in the register bank and it with addressable RAM, scratchpad RAM area. So normally the stack is placed at higher location in the internal RAM to avoid the conflict with the register and bit addressable internal RAM area. The stack can be used to save the register content and the CPU uses the stack to save the address of the instructions just below the call instruction. This can indicate that this will indicate the CPU where to resume after it returned from the call subroutine. The CPU uses the stack to save the address of the instruction just below the call instruction. After writing the call instruction at the below, the CPU always call the stack to perform the operation, and it indicates to CPU here is the subroutine operation we have to going to perform. After reset, the stack pointer is initialized to 07H, so the stack will begin at location 08H. Here, after power off, this 07H location at the stack will be present, so it will start performing operation from 08H, from 08H location, because it's having its feature, it store, it increment first, then store the data. After push instruction, we decrement the stack pointer, then the RAM location and 07 to 06 and 05. However, these location present register R7 to R0 of the register bank 0. The incrementing of stack pointer for push instruction confirm that the stack will not reach the location 0 at the bottom of the RAM, and stack will run out the space. However, there is a conflict which default setting of the stack SP equal to 07H, and where the 8051 is powered up, and starting the location of this tag is RAM location 08H, and this location belongs to register R0 from the bank 1. That is the register bank 1 and stack are using the same memory space. This is the information about the stack. Always the stack memory uses the register bank 1 or register bank 1 R0, from R0 of the register bank 1, always it's used, and the address from 08H. So in this today lecture, we have seen the information about the clock circuit and oscillator, and program counter, data pointer, and stack pointer. These things we have learned in this lecture. So we will meet in the next lecture. Till then, goodbye and thank you.